So we can actually have a summary here that CAD and CAM itself is concerned with engineering functions in both design and manufacturing. So process planning, NC part programming, and other activities associated with CAM is called manufacturing engineering activities, and it has evolved to include many other functions in manufacturing. Okay, so we talk about the manufacturing planning and production scheduling and computer production monitoring and also computer process control. So we also should see that CAM itself denotes the integrations of design and manufacturing activities by means of computer system. So the method of manufacturing a product is actually a direct function of its design. So if we have conventional procedures in place before, we have engineering drawings typically prepared by design draftsmen and later used by the manufacturing engineers to develop the process plan. So it was separated before, and this two-step procedure, when it was employed, it was time-consuming and basically duplicated the efforts of design and manufacturing personnel. So when we have a CAD/CAM technology, it is possible to establish a direct link between product design and manufacturing engineering. So the goal of CAD/CAM not only to automate certain phases of the design and certain phases of manufacturing, but to also automate the transition from design to manufacturing. So ideally, it is possible to take the design specification of the product and convert it automatically into a process plan for making the product, and therefore a large portion of the processing might be accomplished on numerically controlled machine tool. But that's ideal. Okay, that might be some design issues that cannot be solved directly by the computers. And so when we go back to the scope of computer integrated manufacturing, and we see how influential the CAD and CAM into these three different production functions or engineering functions in production system. Now, when we talk about CIM, it means that business functions are also automated, so it covers all of that business functions in a production system. So the ideal CIM system applies computer and communications technology to all the operation functions and information processing functions in manufacturing. So therefore, it started from order receipt through the design and production to product shipment. So the CIM concept is that all the firm's operations related to productions are incorporated in an integrated computer system to assist, augment, and automate the operations. So it is pervasive throughout the firm, so it basically have a hand on all activities that support manufacturing. So in this integrated computer system, the output of one activity serves as input to the next activity through the chain of events that starts with a sales order and culminates with shipments of the product. And the component of the integrated computer system, as we can see here, are all covered by the CIM. So ideally, when we talk about CIM itself as fully functional, the customer's order are initially entered by the company's sales force or directly by the customer into a computerized order entry system. Then the orders contain the specifications describing the product is served as the input to the product design department. The new products are then designed on a CAD system, and the components that comprise the product are designed, the bill of materials is compiled, and assembly drawings are prepared. Then the output of the design department serves as the input to manufacturing engineering, where process planning, tool design, and similar activities are accomplished to prepare for production. So many of these manufacturing engineering activities are supported by the CIM system. So of course, process planning is performed using CAP and tool fixture design is done on a CAD system. So it's making sure that all the product models generated are generated during product design. So the output from manufacturing engineering provides the input into production planning and control, where material requirements planning and scheduling are performed using the computer system, and therefore through each step of the manufacturing cycle. So full implementation of CIM results in the automation of the information flow through every aspect of company's organization. So this basically takes automation to the enterprise level, in which we have all the information in place for the production of a product. Okay, so basically up until now we have talked into the automation in a production system or automation in a manufacturing system, and we have first take a look into what is automation and how why we want to use automation, how the process improvement and automation itself can take place in the factory, okay, what kind of production volume we're looking at if we want to have some kind of automation in place, and what are the rules for automation, how can we do it. And we also talk about the layout and how when automation is in place, what kind of layout we can put in a manufacturing or in a production system or in a factory. And finally we talk about the overall aspect of manufacturing, which is the computer integrated manufacturing. So up to now we finished part 1 of automation in manufacturing. Okay, so in part 2 we're going to talk about the recent development of automation, in which what we call a cyber physical system. So this cyber physical system is basically an improvement to the current implementation of computer integrated manufacturing. So computer integrated manufacturing itself doesn't guarantee an automatic flow of information. So basically, even though we said that computers are involved in all stages of business functions, we have just said that as a separate what we call system for each component. So in cyber physical system that we can see later on, that we are trying to make sure that all the informations are interconnected. So this is actually a step up from a flexible manufacturing system that remember that earlier we talked about flexible automation. Okay, this is like the highest end of automation, in which it is capable of producing variety of product with no time loss for changeovers, and therefore the cyber physical system is we can think of it as an extension of a flexible automation, in which more automation are in place in terms of data processing, in terms of data availability, and so on. So if we want to talk about cyber physical system, that we have to make sure that the information right now that we have should be ingrained in all of us, that the automation itself doesn't actually come in a very complicated manner straight right off the bat. So we have to go through the process of understanding what can be automated, how can we improve the functions, and what kind of budget we're looking at, what kind of products or the volume of the product that we are aiming at. So all of this will depend on the production volume and what kind of product that you actually produce. So obviously with flexible manufacturing system, for example, we talk about the production line that can actually produce variety of products without actually without actually losing time on changeovers, and therefore we can actually have various types of products manufactured in the same place with the same production line. Okay, so we're going to stop here for this week's lecture, and I hope that you can still take this into consideration, or keep this in mind when we start the second part of automation in manufacturing. Okay, thank you.